Hello, everyone. Welcome to the session. This is the intro to OCI Network Firewall. My name is Gopi Gopalakrishnan, and I'll be co-presenting the session with my colleague, Troy Levin. We are both part of the virtual networking product team in Oracle Cloud Infrastructure, where our goal is to offer a flexible, highly performant, and secure virtual cloud network. Our team is responsible for delivering network connectivity, application delivery, and network security services. And today, we'll be covering Network Firewall, which is one of our network security service. All right, here is the agenda for our session today. We will discuss the Network Firewall product, some of its key use cases, the available deployment options, and then wrap it up with a short demo. Let's start with the problem surface before we talk about the product and the solution. As we all know, the number of challenges in security are growing, and the surface area we need to protect gets bigger every day. There is a lot of complexity involved in securing your users, your devices, apps, and infrastructure. Also, the fundamental challenge is the disjoint toolset and the effort required to integrate them. We at Oracle Cloud offer an integrated set of tools with our infrastructure platform and deliver value that is hard to match in the marketplace today. We believe our network firewall can help address the tool complexity and also lower your total cost of ownership at the same time. Our OCI Network Firewall is a cloud-native managed next-generation firewall service that is powered by industry-leading Palo Alto Networks technology. We offer it as an OCI native turnkey service that is elastically scalable, has inbuilt high availability and resiliency, and provides best-in-class machine learning-powered capabilities to protect your workloads on OCI. With this firewall service, you can monitor and apply granular security controls, centrally manage your security policies, and easily enforce them across your virtual cloud networks. The firewall is capable of inspecting both encrypted as well as non-encrypted traffic. And finally, it helps you meet your compliance goals. In terms of features, we support three major feature categories. The first one is stateful firewalling, which allows you to enforce, allow, or deny stateful rules for both v4 and v6 traffic. And being a stateful firewall, we take into account the direction and the context of the flow when enforcing these rules. The firewall service also has an inbuilt intrusion detection and intrusion prevention system to help block malware and spyware type exploits. Last but not least, we support URL filtering, which allows you to restrict traffic to a user-specified list of fully qualified domains and custom URLs, including wildcards. And all of these rules can be easily enforced using our VCN security and VCN routing rules and apply to your inbound, outbound, and east-west traffic. All right, now let's discuss some of the key use cases that can be addressed using our network firewall. This is by no means an exhaustive list, but some of the most common use cases for our network firewall. The first one here is securing your network perimeter, which allows you to protect your workloads in OCI against threats that's coming in from the internet until you have time to patch or update your vulnerable systems. As shown in the diagram here, the network firewall can be composed with either an internet gateway or a NAT gateway for internet access. And in this example, we have a simple rule that only allows RDP traffic coming in from the clients to your server inside the VCN, and all other traffic is implicitly denied. You can create stateful filtering rules based on allow or deny access control entries, and we allow you to combine them into any combination of white, black, or gray lists for greater flexibility and to meet your compliance goals. As we discussed earlier, the firewall instance has an inbuilt intrusion detection and intrusion prevention engine that is powered by Palo Alto's advanced threat prevention capabilities and also backed by their world-class Unit 42 research team. This signature-based threat analysis engine helps you detect and block known exploits, your malicious URLs, spyware, and command and control type attacks. In this example here, we have an e-commerce site that is hosted on the internet, And we have deployed a firewall with an intrusion prevention policy that looks for malware and other threats. If and when we detect a threat, we prevent that from reaching and infecting your client. Along with it, we also generate a threat log, which contains a detailed record of the event and the threat information for future analysis. All right, for the third use case, we're going to talk about selective access to the Oracle Services Network. Troy will also be covering this as part of his demo. So with the firewall, you can compose that with a service gateway to inspect traffic based on specific URLs and grant access only if no threats are detected. As shown in this diagram, the service gateway is one of our private access products that is deployed to provide you private access to the Oracle Services Network. Generally, the service gateway is configured to access all Oracle services. However, here we have deployed a network firewall that is enforcing a selective access policy. And in this case, the traffic that's destined to the Oracle streaming service endpoint is allowed, and any other traffic to other Oracle services networks is blocked. In addition, the network firewall can also help you protect against data exfiltration by restricting outbound data to only trusted networks or applications. For example, you can enforce rules to only allow Ubuntu servers within your VCN to reach out to trusted canonical sites in the internet for image updates and block any other traffic from those servers going out to the internet. All right, last but definitely not the least, you can leverage the network firewall to implement a secure zero trust architecture and create different trust domains within your VCN. In this example, we have a network firewall that is enforcing a zero trust segmentation for a 3-tier application that contains a web, app, and a database tier. We have configured the firewall policy to allow communication from the web tier to the app tier and app to database. But we block any direct communication between your web to the database. In addition, you can also use the firewall to enforce policies that enforce user access based on the role type. For example, you can configure rules to only allow approved database admins to run SQL transactions. Our OCI Network Firewall is natively integrated with the OCI platform, including our platform services like logging, monitoring, and logging analytics. We support a rich set of metrics that allows you to monitor the health and performance of the firewall instance and the associated policies. With these metrics, you can also configure alarms and notifications that are triggered when it meets a user-specified threshold. As far as logs, we support 2 types of logs. The first one being traffic log, which provides information on the traffic flow and the session details. And the threat log provides details about the threats that we identified, as well as the countermeasures that we triggered based on the rules you had configured. These logs can be funneled into our native logging analytics service or a third-party SIEM platform of your choice. And that helps you create monitoring dashboards for both your network or your security operations teams. All right, speaking of the deployment options, you can deploy the firewall in several ways depending on your use case. The most common deployment models are centralized or distributed. Both these models offer you flexibility to secure your flows for the most complex of routing scenarios. In the centralized deployment model, you have a network firewall instance that's deployed in a central hub or transit VCN, as shown here, and it is connected to your spoke VCNs that host all your applications through a DRG. This central firewall instance inspects all the traffic that's destined to your spoke VCNs. In the distributed deployment model, you deploy a dedicated network firewall instance per VCN that only inspects the traffic destined to that specific VCN. You can also deploy a combination of these 2 models in an architecture for more further flexibility. All right, with that, let me hand it off to Troy to walk us through a demo and wrap up the session.
Thank you, Gopi, and good morning good afternoon, or good evening from wherever you are watching this recorded CloudWorld session. I'm excited to cover the next part of this session. So as Gopi discussed in his overview, there are a few key use cases. I'm going to take the remainder of our time in this next section to demonstrate the console workflow for firewall policy and creation using the selective services use case. And as part of this scenario, I'm going to highlight two key features: URL filtering and intrusion prevention. Before we dive into the demo, I'd like to cover the customer scenario. In this scenario, the customer uses the firewall as an SSL forward proxy and has the following requirements. All traffic must remain private. There are no public subnets or exposure to the internet via Internet Gateway or NAT Gateway. There must be reachability to the Oracle services privately via the Service Gateway, which by default allows access to all services. Our customer wants access only to the object storage service and only to configured buckets A and B. So to accomplish this, I have the following topology set up in my virtual lab. The diagram shows a customer VCN that has two subnets: a client subnet that hosts a Linux machine and a firewall subnet that hosts the firewall. Routing is configured to send traffic from the client to the firewall, and the firewall sends the traffic to the service gateway, which again provides access to all Oracle services. Now, in the Oracle Services Network, the customer has provisioned a couple object storage buckets. Each of these buckets stores data. Bucket A happens to store a malware file. Bucket B stores a index.html file. And bucket C also stores the same HTML file as bucket B. Now, I've configured a firewall policy that enforces the customer's requirements. And we expect the firewall to block the client access to all other services except object storage. And within object storage, we expect the firewall policy to grant access to both bucket A and B, but block access to bucket C. Now, we also have configured SSL decryption and inspection, and we were expecting the firewall to inspect that traffic and reject any traffic that it finds malicious. And we've purposely placed a malware file in bucket A. So now that we understand the topology and the customer scenario and requirements, let's move over to a live demo. So the first thing we're going to do is take a look at the workflow for how we create the firewall and then attach the policy to it. The first step in the workflow is to create the policy. And so from the landing page within the Oracle OCI console, the firewall service shows up under our identity and security portfolio. And here you can see the firewalls, and you have two options. You can go to the firewall or the firewall policies. So we're going to start with the firewall policies. Now, in the interest of time, I've already pre-staged the policy, which you see here. But what I can do is I can actually click on this policy and clone it so that you can see on the left-hand side all of the steps that are required to create the policy in the workflow. And we can walk through it very quickly. So the first step is to give the policy a name. In the second step, you define different types of objects lists that match the interesting type of traffic that you want the firewall to act upon. Now, Gopi in his overview talked about a couple of use cases that rely on stateful filtering, which is where you would put IP addresses. You can also do that based on port and protocol. But in our example here, we're looking at selective services access through a service gateway, and we want to do that on higher layer context, such as URL. And so we've used the URL list object to define some URLs that pertain to the buckets that we talked about in the scenario. You can ignore this management URL, which we use here just to provide us access to a couple of services and housekeeping. Now, the first bucket that we talked about was bucket A, and that is the bucket that is hosting our malware file. And so within object storage, we have an endpoint URI pertaining to that bucket that we see here that we've defined in our policy. And likewise, we've done the same thing for bucket B. So now that we've defined the objects, the next step is to, in order for the firewall to do SSL inspection, we need to provide it with SSL keys to decrypt the traffic and profiles in order to determine what things should happen if we detect any issues with the certificates. And so our OCI Network Firewall service integrates with our Vault service for you to leverage any uploaded SSL keys, and you would do that in this step. So after you've done that, you've now moved on to step 4, which is to create the rules based off of the object lists and interesting traffic that you defined in the previous steps. And we have some rules that we create for traffic that we've decrypted. But more importantly, we have some security rules that define what happens when we match on criteria and what action we want to take. Now, in our example, we wanted to do intrusion, URL filtering, but also intrusion prevention. And so here we've defined a rule for bucket A that says match any of the traffic that pertains to that URL. And the action we're going to take on it is to allow that traffic, but to perform intrusion prevention. So if we determine that there's any malicious behavior, we're going to reject it. And the same thing is true for bucket B. And again, for the management traffic, which we don't care so much about in this example, we're just going to allow that. Now, once we've created these rules, we can simply create the network firewall policy, and it's going to create a copy of that policy for us here in the policies tab. Now, this is the policy that's actually live, and you can see once we've created the policy, we need to actually attach it to the firewall. So if you come over to the firewall tab, what you will see here again is, in the interest of time, we've created a firewall and attached that policy. But to show you the workflow for that, you would simply click on Create Network Firewall. You'd give it a flexible name. You'd select the policy. You'd select the VCN. You would select the subnet that you want the firewall to be hosted in, an availability domain, and then you would create the network firewall and you'd be done. So that covers the workflow for firewall policy creation and network firewall creation. In the next section here, we're going to look at validating that our firewall policy is working as we intended. So to do that, I'm going to switch over to the console and I'm going to log into the client. Now, on the client, we have a couple of shell scripts that we're going to run in order to test out the policy. And so the first test we're going to run is bucket A. And when we run that, we can see right away that we're getting errors. In other words, the firewall appears to be blocking that traffic flow. We're going to run the same test, but this time we're going to go and try to download data from bucket B. Now, in this case, bucket B was successful. We got a 200 OK, and we've downloaded this hello world HTML file. Now, in this last scenario, we're going to try the same test, but we're going to use bucket C. And again, we get an error. So it appears that the firewall policy is working as we intended, but let's go back to the console and validate that we actually are seeing the correct behavior. Now, to do that, we can actually come and click on the firewall itself and look at some of the metrics that we offer. The first metric we offer is all the packets that have been sent from the firewall over a period of time. And then we also have all the packets that have been received by the firewall over a period of time. Now, in the lower right-hand corner, we also show you all of the packets that have been decrypted using SSL inspection. So we know that that's working as well. And then the last metric we have here is the security rule hit count. And what we can see here is that for all the rules that we've created in our policy, we will show you how many times those rules have been hit. And in our case, we can see that the object storage bucket A and bucket B on the third line there have been hit. We see some management traffic. And one thing that I want to point out as well is that our firewall policy is a whitelist policy, meaning that by default, everything is denied. And so you have to explicitly allow the things you want, and anything that's not allowed will be denied by the firewall. And you can see here that that last rule, default deny all, is also seeing some traffic. Now, in addition to the metrics, we also have some very detailed traffic logs. There are two types of logs that we offer. The first is the traffic log. And the traffic log is very similar to what you would expect from our flow logs, if you're familiar with our VCN flow logs. And what you see within our traffic logs are all of the records of traffic flows coming in and out of the firewall. And if we look at one of these records, we can get a very detailed view as to what that flow, what the characteristics of that flow was. So in this case, our source, which is our client, 10.00 to 11, was talking to some destination that had an address of 142.168.220. It's located in the United States. It was TCP traffic on destination port 443. The firewall action was to allow this, and the rule that it matched was management. We can also get a little bit more detailed with our flow logs by coming to the explore log, and we can actually look at all the different fields and search by that as well. So in this example, I can look at a very specific rule. For example, if I want to see how much, if I want to see traffic that was going to bucket B, I can click on that rule. And again, I can see my client was talking to this destination. It was TCP traffic. It was port 443. We allowed that traffic, and it was on rule, it hit rule object storage hello world bucket B. So we get very good detailed flow records. You can take these records, you can export them into our logging analytics service, and you can also export these out to your own SIM and create some interesting graphs as well. Now, the last log file that we want to look at is the threat log. Now, the threat log is going to log any events that intrusion detection or prevention flagged. And so in this case, what we can see here is that, again, our client was talking to this destination. It was talking on TCP, protocol TCP, on port, this would be 443 traffic. And what we've determined here is that the action was to reset this connection. And the rule that it hit was this object storage EICARF bucket A rule, which normally we would allow. But because this type of traffic was categorized as a vulnerability and a threat, and we give you the threat ID, the category, and the subtype, the action that we took due to our intrusion prevention was to reset that connection. So that takes care of the validation that showcases that our firewall is actually working the way we intended it. So if I come back to the deck and we summarize what we've covered today, we've covered that the OCI Network Firewall is powered by leading technology, Palo Alto Networks. It's built under the hood using cloud-native methodology and has integrations with our existing OCI services. This makes this service extremely flexible, scalable, and elastic in the way it can be deployed and how features are supported. It's automated using programmatic interfaces, so you can use APIs as well as Terraform. It's fully managed service, meaning users can expect the same user experience via the console as they get with their existing virtual network services. And many of the operational burden that is associated with deploying a third-party marketplace firewall is eliminated using our service and the management aspect of it. Finally, we encourage you to further your knowledge on the OCI Network Firewall service. And so we've provided a list of resources that includes links to our product page, blogs, documentation, reference architectures, and our Terraform scripts on GitHub. And so on behalf of Gopi, OCI, and myself, thanks for giving us the opportunity to share with you one of our most exciting virtual network products, the OCI Network Firewall.